Welcome back. In this video, we'll dive deeper into the Submit Observation form, focusing on the default values and what they mean. The form has 7 sections. Let's start with general information. We've already covered the name and proposal, but there's also the mode and IPP factor. The mode is set to queue scheduled by default. Other options include time critical and rapid response. Note that these require a time allocation in your proposal. Time critical is for observations needing completion at a specific date and time, such as an exoplanet transit. Rapid response is for observations needing to happen as soon as possible. The IPP factor, or intra-proposal priority factor, allows you to boost a specific request's priority within your proposal. If you have many requests, you can increase this factor for the most important ones to make sure they take precedence over your less important observations. Moving to the request section, we have 4 fields: acceptability threshold, configuration repeats, optimization type, and mosaic. The acceptability threshold is set at 90% by default. This is the percentage of the observation you'd be satisfied with. For example, if you request 100 observations but only 90 are completed, the request is marked as successful. Configuration repeats is the number of times a specific configuration will be repeated. It's set to 1 by default. The optimization type defaults to time, meaning the scheduler will try to fit the observation in as soon as possible. You can also select air mass, where the scheduler observes when the target is at the most favourable air mass for the highest quality data. Mosaic is a helper function. It's set to none by default, but you can select line or grid. To show you this, let's select a target. If I select line in the mosaic, more fields open up. Point overlap percent, number of points, orientation, and center. Point overlap percent is how much overlap there'll be between frames in the mosaic as a percentage. Number of points is how many parts there will be in the mosaic. Orientation is the angle, allowing you to align the mosaic to different angles. Center determines if the mosaic is centered on the specific RA and deck or starts there. If I change the mosaic to grid, I get a couple of extra fields: line overlap percent and point overlap percent. Plus, we have the number of rows and columns. I'll set that back to none for now. In the configuration section, the default observation type is image. If your proposal allows, you can choose spectrum, which changes the configuration options. We can choose whether to have guiding on or off. On the 40 cm telescopes, guiding requires specific settings. The type is an exposure by default, but you can also set an exposure sequence. This will repeat the instrument configuration for the duration specified in the time window. If you're unsure how many exposures you'll need, exposure sequence is a good option to use. For example, if you have a 3-hour window of observing where your object is visible, and you know that you need 2 hours of data to capture an interesting phenomenon, set the time window for 3 hours. Then scroll back to set the exposure sequence. Change the type from exposure to exposure sequence, and a duration box appears. Enter 2 hours in seconds, which is 7,200 seconds. The scheduler will then take as many observations as it can during that time. and this configuration can contain multiple filters and even multiple targets. Dither moves the target location around the frame a small amount. You can select line, grid or spiral. This is good to get better signal to noise, not for large mosaics. The two final options here are about sub-exposures. The QHY cameras on the 40cm telescopes allow for partial readout, which is used for guiding. We can set sub-exposures to true and set a sub-exposure time, which must be less than the main exposure time. Moving on to the instrument configuration section. We've previously set the exposure count, exposure time, readout mode and filter. There's also the option to set an offset RA and deck, which points slightly away from the target centre. This is useful for manual dithering and placing other targets inside or outside of the field of view. For example, there might be a bright star in the frame that you want to avoid. There's also defocus, which is very useful for bright targets that you want to expose for longer without saturating, like for exoplanet observations. It spreads the light over a wider area. Defocusing is set in millimeters with a maximum of plus or minus 5 millimeters. Finally, the target section. You can set the type, name and RA and deck. If you change the type to non-sidereal, you get the fractional ephemeris rate. Setting it to 0 tracks with the stars, while 1 tracks the target. Setting this value to 0.5 is a common strategy to keep trailing to a minimum for both the target and the background stars. If we set it back to sidereal, we have extra options like proper motion for RA and deck, the epoch, usually J2000, and parallax in milliarc seconds. I hope this has given you some extra information about setting up your request and some of the more advanced features. If you want to review any of this information, it's available in the Getting Started guide, linked to from the video description.